Let's look at creating a foldable for the real number system. Before we begin, let's go over our basic vocabulary words. We're going to talk about a graphic organizer, the Frayer model, and foldables. A graphic organizer is some type of concept map or chart that will help children to organize ideas. We are going to use a graphic organizer to display the sets within the real number system. We're going to fill in this graphic organizer. We are going to use the Frayer model to define our vocabulary words. I have shrunk down the Frayer model into 6 little pieces so that it would fit in our interactive notebook. Normally, the Frayer model will be 1 full sheet per vocabulary word, but I shrunk it down so that it would fit in our notebook. A foldable is any type of 3D student-made interactive graphic organizer that is used for student notes. The students construct this, therefore they take ownership because they created this, and it engages the students in active learning, whether they're cutting, folding, gluing their graphic or their foldable. Okay, so let's get started. This is what our graphic organizer is going to look like in our interactive notebook. We're going to fill this out, and at the end we will color code it with our definitions in the Frayer model. I chose not to cut these. I left them together in a shutter fold in which it opens to the right and to the left. Okay. Now you may choose to print these from the course files, or you can create your own, in which you can simply use index cards, or I divided this paper up into 6 and you can use that. Here's a graphic organizer, just very simple. So you can either draw these yourselves or choose to print it out. Okay, so let's begin with our real number system. And let's fill in our different sets. We start with natural numbers. Natural numbers begin with 1. It's an infinite set, starting with 1, 2, 3, and so on. It is a smaller set. It's still a very large set if you consider that it's infinite, but in relation to the other ones, it's a smaller one. Then comes whole numbers. So natural numbers start with 1. You add the number 0, see how it's slightly larger, and that is a whole number. The whole numbers start with 0, 1, 2, 3, and so on. Next comes the set of integers, which include your positive and negative numbers, and again, it's getting larger. All of these are rational numbers, which are your fractions, decimals, percents, positives, negatives. On the other side of the chart, which is disjoint, in other words, they're not related, are the irrational numbers. So we have filled in the graphic organizer with a different set. One way to look at the real number system is to remember that there are 2 distinct sets. The rationals, which is displayed on the left here, and the irrational on the right. And again, these 2 are not related. They're disjoint sets. Okay, so let's go ahead and look at our vocabulary words. Natural numbers, whole numbers, integers, rational, irrational, and all of these compose the real number system. So let's go ahead and set up the Frayer model for these vocabulary words. In the center of the oval, we write the vocabulary word. Natural number. The order is not important at this point. Integers. Rational. Irrational. And real. So these are the 6 vocabulary words that we're going to define. Here's a picture of my graphic organizer that is colored, that I shaded with color pencils. And here are my Frayer models. Notice that I color coded. If I put yellow in the center here for natural numbers, then I shaded the oval yellow. And we'll do that at the end. Here I put them together side by side in my interactive notebook, the graphic organizer on the left and the Frayer models on the right. Okay, so our 2 big sets are rational and irrational numbers. So let's look at our vocabulary words. We have natural numbers. Now, you can use any dictionary online. I do have this math dictionary, which I like to use in class. And so we can start with natural numbers. Natural numbers. One of the counting numbers, notice that it begins with number 1, the digit 1, and then it has the 3 little dots, ellipses, at the end. Notice that it's also called a counting number. So let's look at our Frayer model here. And in the center, we put the vocabulary word. On the upper left, we're going to write a definition. We are going to write some examples. We are going to put some facts and then some non-examples. Okay, so that is the set of counting numbers. Okay, our examples start with 1. And I put the 3 dots to show that it's an infinite set. Okay, important information. I have here that it is a counting number, so I'm just going to repeat it right here. Another important fact to notice is that it does not include the number 0. There are no fractions and no decimals. Okay, so non-examples would be a negative, a fraction, a decimal, percent, so any one of these. So we wrote our definition, we wrote some examples. On the upper right, we wrote some important facts and then some non-examples. Okay, the next vocabulary word is whole numbers. A whole number are my natural numbers including 0. Whole numbers including 0. 0 together with all counting numbers, but no fractions or decimals. And here the set begins with 0, 1, 2, 3, and so on. So whole numbers it is the set of, let's say, natural numbers including 0. Okay, so my examples begin with 0. Okay. An important fact, this time I really want to emphasize that it includes 0. Okay. If I wanted to put some more important facts, I could say again, no fractions, nor decimals. If I wanted to use, I could introduce the word infinite. Infinite, all of these are infinite in that it keeps on going forever. Okay, non-examples, no fractions, no decimals, no negatives. So these are my non-examples. Integers. My integers include my positive and negative numbers, including 0. Integers. My positive and negative whole numbers, including 0. And I'm using the word whole numbers because there are no fractions at this point. Positive or negative whole numbers, including 0. Here's my negatives. Here's my positives. Okay. So it is the set. A set is a collection of objects. So this is a set of numbers. And set of positive and negative numbers, including 0. Now, our students at a young age may not know about positive and negative numbers, or you're barely introducing that. You could say the set of counting numbers and their opposites, or the set of natural numbers and their opposites. Okay, at this point, again, there are no fractions and decimals. Okay, my examples. So my non-examples would be a fraction, a decimal, we could do it positive or negative, are my non-examples, positive and negatives. Okay, rational numbers. A rational number is any number that can be written as A over B. Sometimes they'll say as the ratio. Ratio is a fraction. A over B. So it is the set of numbers that can be written as A over B. It is important to remember that B cannot equal to 0. So remember that 0 divided by any number is 0. That is okay. However, if the 0 is in the denominator, it cannot equal to 0. So we cannot have a 0. If you were to put this in your calculator, it would say undefined. Okay. So my set of rational numbers can be any fraction. What about the number 9? Can I write 9 as a fraction? So that would be 9 over 1. I can have a decimal. If I have a decimal, I can convert it to a fraction. I can put any percent as a fraction. So rational numbers include fractions, decimals, percents. It includes any number that can be written as a fraction. It can be represented by a decimal that ends. It's a terminating decimal. A terminating decimal is a number that when I divide 3 divided by 4, I get a decimal 75 hundredths. No remainder, it terminates. It's also a rational number, can also be a repeating decimal. Here, when I divide 2 divided by 3, we get 6666666, and it keeps on going, and so we put a bar to indicate that the 6 is repeating. So let's write that down as an important fact. Includes terminating and repeating decimals. So let's put a repeating decimal in our example. How about 3, 3, 3, 3, 3? Notice the bar across the top. So then what would be irrational? The opposite of a rational number would be my irrational. So a number that's not a rational number would be pi. It is a non-repeating, non-terminating decimal, which is the opposite. Another non-example would be a square root. So these examples are going to go down here. Okay, so an irrational number is a set of non-repeating, non-terminating decimals. A number that cannot be written. An irrational number is a number that cannot be written. The set of numbers the set of non-repeating non-terminating decimals, which includes pi and square roots. Okay. Now be careful here. If you have the square root of 9, we know that the square root of 9 is a 3. So that is considered a rational. So maybe over here we can put that the square root of 9 is 3. It looks irrational, but it can be simplified. So if a square root can be simplified, it is considered rational. How do you know? If a student is unsure, they could try it on their calculator to determine and simplify their square roots. If a square root keeps on going and keeps on going, it is considered irrational. Okay. An important fact is that a number cannot be both rational or irrational. Okay. A number is either going to be rational or it's going to be irrational. A real number is either going to be rational or irrational. Rational numbers include terminating decimals. It includes repeating decimals. Irrational numbers are my non-repeating, non-terminating decimals. Okay. The real number system is a set of all of these together. All of these together are my real numbers. So it is the set of rational and irrational numbers. Okay. If I wanted to write some examples, it would include positive numbers, negative numbers, fractions, decimals, repeating decimals, percents, everything. I could draw a picture here under a fact or a characteristics. If I were to draw a picture a graph, it would be a dark line, which includes all the fractions and decimals in between 0, -1, -2, 0, 1, and 2. Okay, let's do that correctly. There we go. So it would be a solid line. My non-examples would be my imaginary numbers. Remember in college algebra, we learned that the square root of a negative number was I. So a non-example of a real number would be imaginary numbers. Okay. The next thing you will do is color code your graphic organizer with your Frayer model. So if I were to shade this any color, it doesn't matter. Use color pencils. Do not use markers that bleed through. So if I were going to shade my natural numbers yellow, I would go to my graphic organizer with my Frayer model and shade it yellow also. So this way they have the same color. Then I would go to whole numbers, pick a color, and shade the inside of the, and that's just a color code to make it a little bit more pleasing for the student. We insert these in our notebooks.